This might be the cheapest astronomical telescope on the entire internet. Its price is even cheaper than this air blower I used, only $3.8. Besides its incredibly low prices, it also has many other unspeakable secrets. Today, I'm going to test it using the same process I use for professional optical gear. Hi everyone, I'm Ethan. Welcome back to the channel. To find this telescope, I searched through almost every online shopping platform. And finally, on that platform, I found it. The name is Galactic Wonder Telescope. It sounds romantic, almost powerful. But the price is only $3.8. Honestly, I'm not curious about how strong it is. I'm more curious about one thing. Does this actually count as a real telescope? Type 1 if you think yes. Type 2 if you think no. First impression. Much smaller than I expected and very light. Lighter than the phone I'm filming with. Inside the box, you get everything. The main tube, a tripod, and 3 eyepieces. Instead of focal length, the eyepieces only list magnification. 20 times, 30 times, 40 times. The manufacturer has thought this through very well. This way, the magnification doesn't need to be calculated. It's all very clear. Later, I realized why I didn't need to calculate. Although honestly, I still have no idea what the objective focal length is. The eyepieces feel completely plastic. Even the lenses are plastic. No coatings at all. At this price, that's expected. The eyepiece installation is quite special. The mounting system is a snap-in design. It feels loose, but it's actually convenient. Just to give you a reference of what a normal astronomical eyepiece looks like, here's a very basic 1.25-inch eyepiece I own. Put them side by side, and the difference is obvious. But to be fair, this single eyepiece costs 6 times more than the entire telescope set. The tripod is extremely simple. In fact, it might be the most premium part of the set, because the only metal component in the entire set is used in this tripod. You see it's these 2 metal screws. Even though the tripod used metal screws, it was still flimsy and wobbly. This is determined by cost, and I think everyone can understand that. Now let's look at the main tube. Black and white design, with a big telescope label to remind you what it is. It actually includes a built-in diagonal for viewing objects overhead. The objective measures 28 millimeters. Still plastic, no coatings, likely a single element. So it's not even a basic achromatic refractor. Maybe we should call it a non-achromatic telescope. It feels like something from the Huygens era. There's also internal aperture stopping, so the effective aperture is probably smaller. At this point, I started to wonder, are these really 20 times, 30 times, and 40 times? Alright, let's test it. First impression during observation. It's so light that you don't even need the tripod. Handheld works just fine. And there was an even bigger surprise. The image is upright vertically. That alone beats many traditional telescopes. So it's actually great for terrestrial viewing. Of course, left and right are still reversed, but focusing is a nightmare. You focus by rotating the objective lens. From near to infinity takes 8 full turns. Every turn shakes the image. Finding true focus is difficult. You can only narrow it down to an approximate range. Whether it's perfectly sharp depends on luck. We tested 20 times, 30 times, and 40 times. Sharpness and chromatic aberration were exactly what you'd expect. The image quality is probably the worst I've ever used, and of course, it's also the cheapest. I swear these photos have been meticulously focused. This is the clearest I can get. It's like looking at the world through frosted glass. The purple fringing is just, well, it's fitting for this retro optical design. It's all purple fringing. However, the imaging issues aren't too significant. I don't know if you've noticed. After switching eyepieces, aside from the field of view getting smaller, the actual image scale barely changes. To confirm this, I took photos through each eyepiece and compared them at a 1:1 scale. And yes, you see it. The object size doesn't change at all. That technical strategy, I really didn't see that coming. We'll also show real 20 times, 30 times, and 40 times examples at true 1:1 scale. Here's the comparison at 30 times, and this one is at 36 times. And as you can see, this telescope isn't even close to those numbers. So, what about 20 times? Well, turns out even the 20 times magnification is optimistic. Let's go even lower. This one is 12 times. And as you can see, the 12 times view is still clearly larger. So at this point, the real magnification of this telescope is kind of a mystery. After seeing them, what do you think the real magnification is? Let me know in the comments. Since it's called the Galactic Wonder Telescope, we have to use it for astronomy. The moment it points at the sky, problems begin. The tripod can barely tilt upward, increase the angle, and it tips over. Honestly, handheld is easier. Given the above situation, let's make some minor upgrades to it. We'll replace the tripod with this $1,000 harmonic mount, instantly raising its value 300 times, straight to the peak of its life. Let's start with the moon. Since all the magnifications look pretty much the same, we'll just use the best one, the 20 times eyepiece. To be fair, the actual visual view is slightly better than what the phone captures through the eyepiece. You can faintly make out a few of the larger craters near the center. Now let's upgrade the challenge and look at Jupiter. Still using the same 20 times eyepiece. No matter how carefully you focus, this is about the best image you can get. You can see Jupiter completely buried in glare, and I couldn't spot any of the Galilean moons. The optical design may be vintage, but the performance doesn't quite reach the level of Galileo's telescope from over 300 years ago. What? You want to see it film deep space? I think you should forget about it. Turns out, even the most powerful external gear can't change fundamentally weak optics. For $3.8, you really can't expect miracles. If the goal is simply to show a child that the moon has craters, it might work. But if you want them to truly fall in love with astronomy, it might discourage them instead. So I'm curious. If you were a parent, would you buy this as a child's first telescope? Leave your answer in the comments. Every first telescope deserves to be taken seriously. Subscribe if you'd like to see more. See you next time. Goodbye.